Okay, taking a look at question 18 out of chapter 9, section 1. A trial was conducted with 75 women in China given a 100 bill, while another 75 women in China were given 100 in the form of several smaller bills. Among those given the single bill, 60 spent some or all of the money. Among those given smaller bills, 68 spent some or all of the money. We want to use a 0.05 significance level to test the claim that when given a single large bill, a smaller proportion of women in China spend some or all of the money compared to the proportion of women in China given the same amount in smaller bills. And then they ask us if we were to change the significance level down to 0.01, does the conclusion change? So first thing we want to do is go ahead and identify what our claim is. And boy, this is a long claim here, but such is life. So our claim is that the proportion of women given a single bill, the proportion that spend some or all of the money for those given a single bill is less than the proportion that spends some or all of the money given multiple bills. And our opposite case here, so P of SB, P of MB, so the opposite of less than is greater than or equal. So with that, we can go ahead and write our hypothesis statement. Again, HO, HA, they're merely labels. They're never equal to anything less than or anything because they're labels. So whatever proportion we listed first, we list first here. That is going to be our first sample. Whatever proportion we listed separate, that's going to be our second sample. We list second. And then now what goes in between them? Well, in the null, it's equal because it's always, always, always equal in the null. In the alternate, we need the strict inequality, that is the less than. And then now we'll put our R and the S, and which one looks most like, if not identical to the claim? It is the S. So when we get down to stating the conclusion with respect to the claim, we'll talk about whether or not we have the evidence to support the claim. So identifying the pieces, once again, we've got our alternate hypothesis pointing to the left. This is a left tail test. Our significance level that they want us to use is 0.05. And then we've got sample 1, sample 2. That is the single bill, that is the multiple bill. There was a total of 75 in each group. 60 did spending with the single bill, 68 did spending with the multiple bills. Now we can go ahead and write our rule of rejection. Again, I'm going to use p-value versus significance level, so that gets phrased. Reject, null hypothesis, if p-value is less than or equal to whatever that significance level is, that's alpha, and in this case it's 0.05. So now we're ready to head on over to StatDisk to get our test statistic, which in this case is Z, because for proportions we use the normal approximation of the binomial to compute these. If you don't remember it's Z, that's fine, StatDisk will tell you, but now we can go ahead and let's head on over to StatDisk. Analysis, hypothesis testing, proportion to samples. And this was the less than case. Our significance level was 0.05. And for our first sample with a single bill, our numbers were 75 and 60. For our second sample, which is the multiple bills, our sample size was 75 and number of successes was 68. And we can go ahead, hit evaluate and plot. And again, the thing that I'm taking away from the plot screen here is, does our test statistic fall into the tail? So this was a lower tail, left tail. The red vertical line there is the line that represents our critical value, and our test statistic does fall in that left tail. When we look at our p-value, we're also going to see that our p-value was indeed less than alpha. Both of these things are telling us that we're going to go ahead and reject the null hypothesis. But let's come back here, put that in. So now our z was negative 1.846. And my p-value is 0.0324. And again, I'm lining it up with the alpha above it, so I make sure that I'm comparing, in this case, I'm comparing the 3 to the 5 there, because everything before that was zeros. So our p-value was indeed less than alpha. We said we would reject the null hypothesis if that was the case, so reject the null hypothesis we shall. So we're rejecting the idea that these proportions are equal. So if we reject the null, that means we're going to end up going with the alternate there. But now let's go ahead, write out the conclusion with respect to the claim. When we reject the null hypothesis, we have the evidence. So we have sufficient evidence to, we noted the S in the hypothesis statement. S is for support. So support the claim that. And then to finish this off, we do the cut and paste, or the copy paste of the claim. So the claim that when given a single large bill, a smaller proportion of women in China spend some or all of the money. And I'm going to invoke a little instructor privilege there and just put the ... put the ellipses down. It says that means when compared to the proportion of women in China given the same amount in smaller bills. I did that because it's kind of boring to just watch me write something that you already know is what it says. So again, let's read this conclusion all together. We have sufficient evidence to support this claim that a smaller proportion of women are spending the single bill versus the multiple bill, if I were to paraphrase that there. This is kind of the analogous, and you might have noticed it yourself if you have, if you have a $50 or $100 bill, are you going to go ahead and break that, spend that as easily as you would if you had a mix of 10s, 20s, 5s, 1s? Is it easier to spend money when you have the smaller denominations in there? That's what this is saying seems to be the case, is that you're less likely to spend the money if you've got the single larger bill. You can reverse that. You're more likely to spend some or all of the money if you're working with smaller bills, even if the grand totals are the same in both. But they're saying that how you have that money affects whether you're likely to spend it. Now, part G, if the significance level changed to 0.01, does the conclusion change? So if we were to change this to 0.01, are we still rejecting the null hypothesis? And the answer to that is no, we're not still rejecting the null hypothesis. In this case with the 0.01, we would end up failing to reject the null hypothesis. And then over here, we would say we don't have the evidence to support the claim. So did our conclusion change? Yes, it did. Now, one of the things that we touched on in our coverage of 8.1 is the power of a test. And we touched on type 1 errors, type 2 errors. One of the things, one of these schools of thought on this is when you're trying to account for the likelihood of a type 1 error, the likelihood of a type 2 error, that goes into your choice of significance level. Fact that your significance level is getting chosen before you go into this process. There is a reason for using a particular alpha here. And if you go ahead and pick one ahead of time, you should stick with that. It was chosen for a reason. You live with the results, whether you reject, whether you fail to reject, the results are what the results are. What we see here, and this is something that would not be ethical to do, is if you picked 0.05 and there was a rationale behind that choice, to come in and alter your choice of alpha after the fact to get the other result, that would not be ethical. So that's something that in the setup of things, the significance level is chosen for a reason. There is actually a second school of thought that says, don't worry about the significance level. Go ahead, run your test, get your p-value, and then report the level at which your results are significant. So if that was the case, they kind of what you're seeing down here, everything past part D wouldn't really be there in the same way. One of my doctoral professors really just hates that approach because it fails to take into account the power of the test, but when you're out there in the real world, you might come across articles where they go ahead and say our results were significant at the 0.05 level. They were significant at the 0.01 level. They were significant at the 0.001 level. If they're doing that, what they're telling you is they didn't really pick a significance level ahead of time. And they're kind of leaving it more to you as the reader to decide how meaningful their results are. So I know what seemed, and this is often the case, what seemed like a very simple, straightforward question down here of does the conclusion change? And that's, that is a simple yes in terms of the answer to that question, but in the grand scheme of things, it's a much more complicated question.